Good morning. Our project, Nanomaterials to Design New Vaccine Adjuvants, is a collaboration between one laboratory in Austin, led by Nicholas Pepas, and where Dennis Wang also performs his research, and two laboratories at the University of Lisbon, led by Helena Florindo at the School of Pharmacy and Luís Graça at the School of Medicine. Our objective is to improve the vaccines that are available and that, although are among the therapies that have the greatest impact on health, they still are suboptimal for vulnerable people with decaying immune function, such as the elderly. And our preliminary data suggested that it is possible to use nanomaterials to improve this vaccine efficacy. As part of this project, the first step was to develop new nanomaterials that would be suitable for immunization. In the laboratory in Austin, it was possible to generate a pH-responsive methacrylic acid-based hydrogels for oral administration. And in Lisbon, the laboratory of Helena Florindo developed pegylated PLGA-based nanoparticles for subcutaneous administration. Figure 1 and 2 represent some of the properties of the hydrogels developed in the laboratory in Austin. In Figure 1, it is possible to see the volume swelling curves for both cationic and anionic nanoparticles using dynamic light scattering from pH 3 to 8, while in Figure 2, it is possible to see Fourier transform infrared spectroscopy for both lyophilized cationic and anionic nanoparticles. In addition, in Figure 3, it is represented atomic force microscopy images of the PLGA nanoparticles that were generated in the laboratory in Lisbon, showing the spherical shape and slight roughness on the surface and a narrow size polydispersity. At last, in the laboratory of Luís Graça in Lisbon, it was started the process to validate these different materials in the immunization of mice to investigate if these nanomaterials can improve the amount and the quality of the antibodies that are formed following the administration to mice. And what is represented in Figure 4 is the quantification of antibodies specific to the proteins that are included in the nanomaterials. And that shows that nanoparticle-based immunization, and in this case it was used PLGA nanoparticles, there is a very significant increase of the amount of antibodies compared with two other adjuvants that do not include nanoparticles in their composition. As a conclusion, we believe that this strategy to use nanoparticles to embed proteins from virus or other infectious agents may be a good strategy to improve vaccine efficacy, especially useful for conditions where the current vaccines cannot reach optimal efficacy, such as with the elderly and other people that are immune compromised. Thank you.